This is Unit 2, Lesson 7, Key Features of Functions. And the objective is students will be able to identify key features on linear and exponential graphs. So we have a bunch of different features we're going to be looking at today, and a lot of this is going to be words and kind of like definitions that we're writing down. So really, we're just going to be making a list of these key features and then looking at some examples of them. Our first key feature is the intercepts. Most graphs have an x-intercept and a y-intercept. All graphs are going to have at least one or the other, especially when we're looking at linear and exponential. So the x-intercept is the point at which the graph crosses the x-axis. If you were looking at a graph, that would fall at the point x0. So 0 tells us that it would be on the x-axis. X could be any number that falls on the x-axis. The y-intercept is the exact opposite. The y-intercept is the point at which the graph crosses the y-axis. And that always happens at the point 0, y. So the x value is always 0, and the y value could be any number at all. So if we have this coordinate plane, and let's say our graph looks like this, the point where we cross the x-axis is the x-intercept, and the point where we cross the y-axis is the y-intercept. So when we throw some lines in there, that makes our y-intercept 0, 3, and our x-intercept is -4, 0. Sometimes you might have a graph that only has the y-intercept, no x-intercept. And that's actually going to happen quite often when we have an exponential graph. In this exponential graph, this side of our line, the left, is getting closer and closer to the x-axis, but it's never going to touch the x-axis. If it never touches the x-axis, it can't have an x-intercept. So this one would only have a y-intercept, right where we touch the y-axis. And let's say that intercept was at 0, 2. So the first features are the intercepts, the x-intercept and the y-intercept. Next features we are going to look at are increasing or decreasing. We can tell if a function is increasing or decreasing by either looking at the graph of the function or by looking at a table with a list of values that fall in that graph. The graph is increasing if it goes up from the left to the right. So once again, if it's going up from the left to right, it's increasing. We say that a graph is decreasing if it goes down from the left to the right. Let's look at an example of what each of those would look like. So if I graphed an equation or a function and it looked something like this. If we start over on the left side here, as we go across to the right side, this line goes up. So this is of an increasing function. If I were to look at another line, like this, as this one goes from the left to the right, you'll notice that it's going down, so this is decreasing. We have one more possibility, and that would be a straight horizontal line. A horizontal line that doesn't go up or down is what we call constant. It is not increasing, it is not decreasing, it is just constant. Our next features will be the features of a positive and a negative function. A positive function is a function or an interval of a function where the y values are greater than 0. When I say interval of a function, I mean just a specific section of the function. So a continuous section, a nonstop section where the y values are greater than 0. Let's look at a graph of this before we move on to negative functions. So let's say I have this coordinate plane, and on this coordinate plane I have this line. This is an increasing function because it's going up from the left to the right. Part of this function is a positive function. A positive function is where the y values are greater than 0. So if you look at your x-axis, this axis divides our y values into the positives and the negatives. The positive y values are up above, the negative y values are down below. So this point right here is the point where the y values on this line go from being negative to becoming positive. The point that I'm pointing to right here is where x equals 2. So I would say that this function is positive when x is greater than 2. I've decided that it's positive when x is greater than 2 because 2 is the point where the function goes from having all negative y values to all positive y values. At this point right here, y changes from a negative switch to a positive. So this function is positive when x is greater than 2. Well, the opposite of a positive function is a negative function. This type of function is a function or an interval, so a section of a function, where the y values are less than 0. Let's go back to this graph we were looking at. So x equals 2 is the point where it switches from being negative x values to being positive x values. So we say that it's a positive function for all of the x values that are greater than 2. Well, if we start at 2 and we go down, you'll see the y values are getting smaller, but we're also getting x that is less. So this function is negative when x is less than 2. Let's look at another graph that's a little bit different. So I want to know where this function is positive. It's positive where the y values are greater than 0. So this is where the y values are 0 and they're greater as they go up. Well, on this example, right here, that's where x also equals 0. All of the y values become positive as we go this direction. So as the y values go more and more positive, more and more up, my x values are going more and more negative. So in this case, I would say that the function is positive when x is less than 2. And I believe I just said when x is less than 2. I meant to say when x is less than 0, because 0 is that place where it crosses. Now, once we cross the origin, the y values begin to become negative. Well, as these y values go further and further negative, my x values are going further and further positive. So in this case, I would say that the function is negative when x is greater than 0. So we've looked at the intercepts. We've looked at whether a graph is increasing or decreasing. We've looked at whether it is positive or negative. Now we're going to look at a graph's minimum and maximum. A relative minimum is the point that is the lowest y value or the least y value in an interval. You report your minimum in terms of just the y value. So if you look at this example, this has a lowest y value. The lowest y value on this graph falls right here. That point is 0, -4. We would say that the minimum equals -4 because that is the lowest y value. Well, if you imagine a linear equation, there's not a lowest value. There isn't a lowest value on this graph because that arrow on the end shows that it goes on and on all the way to -infinity. We can't have a lowest value that doesn't exist. So that's when we look at a graph that's on an interval. Now we've cut off this graph so it has an ending point. It ends right here where x equals -2. So that point is the lowest point on the graph. That is the point -2, 0. So I would say that the minimum of this graph is 0 because 0 is the lowest y value I have. We also have a relative maximum. The relative maximum is the point that is the highest y value, or it is the highest y value in an interval. So if I had this function, the minimum is -infinity because it's going on forever down. By the maximum, we have the highest point that's right about here. That is the point -2, 3. So I would say that the maximum of this graph equals 3 because that is the highest y value. Now let's imagine that I have an exponential function. So it's increasing at an increasing rate, and then it stops. Well, this function is forever getting smaller and smaller and smaller, so there never is a defined minimum, but it stops right here at the point 2, 3. So I would say the maximum, or the max, of this function is 3 because that is the highest y value. So this example and this example both show a definite minimum and a maximum. This example and this example show a relative minimum and maximum, where we had to look at a certain interval rather than looking at the whole graph. If we looked at the whole graph, both of these would have gone on forever. All right, there's one last key feature we need to talk about. The last key feature is one that you already have learned, and that is domain, which is a set of all the inputs or x values. And we already know how to find the domain by looking at a graph. So if I have this exponential function that's going like this, it shows that it's going forever to -infinity and it's going forever to +infinity. So my domain is all real numbers. Well, if I looked at one that's something like this, maybe it's only in our first quadrant, and we'll say the function starts right here. In this case, my y value is at 2, but I don't really care about where the y value is. I'm talking about domain, and domain is the x values. So my domain is everywhere where x is greater than or equal to 0. My first x value is at 0, and then it goes on forever. So when we're talking about y, we can talk about the y-intercept, whether the line is increasing or decreasing, whether it's positive or negative, and then what the minimum and maximum are. When we talk about x, we usually just refer to the x-intercept and the domain. All of these key features will be used to help you read graphs, to help you create graphs, and to help you interpret and understand graphs. And we will be using all of these features together to describe some graphs that we look at in class.